What if I told you a man-made structure buried deep in the mountains of China changed the way the Earth spins? That a dam, yes, a dam, literally slowed down the rotation of our planet? This isn't science fiction. It's measurable. It's real. And the consequences go deeper than you think. The Three Gorges Dam isn't just another dam. It's the largest hydroelectric power station on Earth, with an installed capacity of a jaw-dropping 22,500 megawatts. To put that in perspective, that's enough to power entire countries. Stretching an incredible 2.335 kilometers in length and towering between 181 and 185 meters high, this colossal structure ranks among the longest and tallest dams ever built by humankind. But size alone doesn't tell the whole story. When the dam was completed, it created a vast artificial lake known as the Three Gorges Reservoir. This man-made body of water spans about 1,084 square kilometers, comparable to the area of a small country. It holds a staggering 39.3 cubic kilometers of water. Imagine relocating 39.3 billion tons of water, lifting it from river level and holding it back behind a wall of concrete and steel. To truly grasp the impact of the Three Gorges Dam, we need to look at how our planet works, specifically how it spins. Earth rotates incredibly fast, over 1,600 kilometers per hour at the equator. But that speed isn't fixed. It can change, depending on how the planet's mass is distributed. Think of a figure skater spinning on ice. When they pull their arms in close to their body, they start to spin faster. But when they stretch their arms out wide, they slow down. Why does that happen? It's because when their arms are closer to their body, their mass is closer to the center of rotation, so they can spin more quickly. When they extend their arms, their mass moves farther out, and that slows the spin. They're not using more or less energy. It's just being spread out differently. This effect is called conservation of angular momentum. It's a basic rule in physics that says if no outside force is acting, the total spin stays the same. But how fast you spin depends on how the mass is spread. Now, here's where it gets really interesting. The Earth works the same way as a spinning skater. When mass on the surface of the planet shifts, especially upward or outward, it can affect how fast the Earth spins. In the case of the Three Gorges Dam, the water wasn't deep inside the Earth, it was already on the surface, flowing in rivers and spread across the landscape. But when the dam was built, that water was collected and stored in a huge reservoir, raised to a higher elevation and concentrated in one place. That means billions of tons of water were now farther from the Earth's center than they were before. It's like the Earth stretched its arms outward, just a little. And just like the skater, that small outward shift caused the planet's rotation to slow down, very slightly, but enough for scientists to detect with precise instruments. Over the centuries, there have been many natural events that have altered Earth's rotation. Melting glaciers, massive earthquakes, even shifting ocean currents. But in the modern age, we've added a new variable: megastructures. The idea for this dam wasn't new. It was first proposed in 1919 by Sun Yat-sen, the founding father of modern China. His vision was ambitious: control the massive Yangtze River, protect millions from flooding, and produce enough electricity to power vast regions of the country. But turning that vision into reality took time. Construction didn't begin until December 1994, nearly 75 years later. By 2003, the dam began generating electricity. It was completed in 2006, and by 2012, it was operating at full capacity. The Three Gorges Dam became more than just a power plant. It became a symbol of China's engineering might, energy independence, and national pride. But with that pride came consequences. NASA and geophysical studies revealed something astonishing. The mass of water held in the reservoir increased Earth's moment of inertia, the property that determines how resistant an object is to changes in its rotation. That change caused Earth's rotation to slow down by approximately 0.06 microseconds per day. It means each day on Earth became slightly longer, by a few millionths of a second. The change is incredibly small, far too slight for us to notice in daily life, but it's a real and measurable effect. When the planet spins more slowly, it adds a tiny fraction of time to each day. On top of slowing Earth's rotation, the massive weight of water in the Three Gorges Reservoir also caused something else. It shifted the planet's geographic North Pole by nearly 2 centimeters. That might not sound like much, but in today's world of precision technology, even tiny changes can have a big impact. Take GPS, for example. It depends on extremely accurate calculations of Earth's position and rotation. When that rotation changes, however slightly, the entire system must adjust. Even atomic clocks, which are the most accurate timekeeping devices we have, are affected by these subtle shifts. That's why scientists now have to include factors like the mass of the Three Gorges Reservoir when they model how Earth spins and moves through space. And that raises a much deeper question. If a single dam can have this kind of measurable effect on the entire planet, what else are we doing that's quietly reshaping the Earth? And what could that mean for our future? The dam didn't just affect the Earth's rotation, it transformed the region's environment and society. Entire cities, towns, and villages were flooded to create the reservoir, displacing over 1.3 million people. Their homes, histories, and way of life now lie beneath a man-made lake. Environmentalists warned about stagnant water in the reservoir producing methane, a greenhouse gas far more potent than carbon dioxide. Sediment, once carried freely by the Yangtze, now settles in the reservoir, reducing soil fertility downstream and harming fish populations. Some scientists also believe the dam may be linked to a rise in local earthquakes, a phenomenon known as reservoir-induced seismicity. There's no question the Three Gorges Dam brought major benefits: clean energy, flood control, and a symbol of engineering excellence. But it also serves as a powerful reminder. When we reshape nature on this scale, the consequences can reach far beyond what we expect. Today, we live in the Anthropocene, a new geologic epoch defined by humanity's influence on the planet. We have the power to reshape coastlines, move mountains, and now change the spin of the Earth itself. And the Three Gorges Dam may only be the beginning. Around the world, new megastructures are rising. Artificial islands in the Middle East. Giant telescopes on mountaintops. Proposals for solar mirrors in space. Each project, in its own way, nudges the Earth toward a new balance. As we push the boundaries of what's possible, we must ask, what are we really changing? Are we equipped to deal with the consequences of shifting the dynamics of our only home? The answers may not come for decades, but the questions are urgent. The Earth still spins. The sun still rises and sets. But we now know that a single dam, conceived in the mind of a revolutionary over a century ago, had the power to alter that spin, even by the tiniest fraction. And maybe, just maybe, the most important story here isn't how we change the Earth, but how the Earth might one day respond.